To process a large 2 GB JSON file and break it into smaller JSON chunks, the typical workflow involves three main steps: uploading the file to cloud storage, loading it into a queryable table, and extracting parts of the data to be saved back as smaller JSON files. Step 1. Upload the file to cloud storage. On any cloud platform, Google Cloud, AWS, or Azure, the first step is to upload your large JSON file to a cloud storage service. In Google Cloud, you use Cloud Storage, GCS. In AWS, it's S3, Simple Storage Service. On Azure, it's Azure Blob Storage. These storage services act as the staging area for data processing. Step 2. Load the file into a queryable service. Once uploaded, the file is imported into a processing service that can read and query large data. On Google Cloud, this is BigQuery. In AWS, you typically use Athena or Glue. On Azure, the equivalent would be Azure Synapse Analytics or Azure Data Factory. Each of these services allows you to read the JSON file as a structured dataset. This means you can write SQL queries or use other data manipulation tools to break the file into manageable parts. It's important that the JSON file is either new-line delimited, in BigQuery and Athena, or appropriately structured for schema recognition. Step 3. Query and split the data. Once your data is in a queryable format, you can extract subsets of it in chunks. This can be done using SQL queries with limits and offsets, or using row numbers or partitions. Each chunk represents a portion of the original data, ready to be saved as a smaller JSON file. Step 4. Save the split files. After splitting the data into smaller parts, you can save these as separate JSON files. These can be written back to the cloud storage, GCS, S3, or Azure Blob, or downloaded to your local disk. Where and how to run the processing script. You can run the Python script that performs this process either locally on your machine or directly within the cloud environment. Locally, you would install the appropriate SDKs and authenticate with the cloud provider. Then, using a terminal or an IDE like Versus Code or PyCharm, you would run the script which handles uploading, querying, and downloading. In the cloud, each provider offers built-in environments. Google Cloud offers Cloud Shell, Vertex AI Workbench, and Cloud Functions. AWS provides Glue, Lambda, Cloud Shell, and SageMaker. Azure supports Synapse Notebooks, Azure Data Factory Pipelines, and Azure Functions. If you are dealing with very large datasets or need to automate the workflow, running your script in the cloud is typically more efficient and scalable. In summary, the task involves using cloud storage to handle the initial file, a query engine to process and split it, and appropriate execution environments, either local or cloud-based, to run your Python script. The final output is a set of smaller JSON files that are easier to work with and can be stored locally or in the cloud. Cross-region communication between cloud resources in AWS, Google Cloud, GCP, and Azure is fully supported but must be explicitly configured. Each provider has its own mechanisms, tools, and pricing considerations. Here's how it works for each. AWS, cross-region communication. How it works. AWS allows cross-region communication through its global network, but it's not automatic. You need to configure services properly. Common methods. VPC peering, inter-region, connects VPCs across different AWS regions. Transit gateway with inter-region peering, more scalable and secure, supports multiple VPCs. S3 cross-region replication, automatically replicates objects to buckets in other regions. Route 53, DNS, plus Global Accelerator, for routing traffic intelligently across regions. IAM roles and policies, ensure permissions allow access across regions. Use case example. A Lambda function in US East 1 can call an API gateway endpoint in EU West 1, as long as the URL is public or the VPC is properly peered. 2. Google Cloud Platform, GCP, cross-region communication. How it works. GCP has a global VPC model, meaning subnets can span regions, which makes cross-region communication more seamless. Common methods. Global VPC networks. A single VPC can have subnets in multiple regions. Cloud Load Balancer, global, allows routing to instances across regions. Cloud Interconnect or VPN, for hybrid or multi-region connectivity. IAM policies and service accounts, control cross-region permissions. Use case example. A compute engine instance in US Central 1 can directly access a Cloud SQL database in Europe West 1, assuming firewall rules and permissions are set. 3. Microsoft Azure, cross-region communication. How it works. Azure uses region-specific virtual networks, VNets, so cross-region communication requires explicit linking. Common methods. FNet peering, global, enables private traffic between VNets in different regions. Azure Front Door or Traffic Manager, for global traffic distribution. ExpressRoute Global Reach, for on-prem to multiple Azure regions. Geo-redundant storage and replication, for data movement across regions. Use case example. A web app in East US can access a Cosmos DB in West Europe via VNet peering or public endpoints secured by IP restrictions or managed identities. Security and IAM. All cloud providers require proper IAM roles or policies across regions. Firewalls/security groups or equivalent access control. Monitoring and audit logging to track inter-region traffic. Cost considerations. Cross-region communication typically incurs egress data transfer costs. AWS and Azure charge for inter-region bandwidth. GCP has lower costs due to its global network, but still charges for egress.